Hello everyone, my name is Hyder Abbas. I welcome you to this video on Kafka with Spring Boot. The prerequisite for this entire video is to have the knowledge on Spring Boot, because for the demonstration we are going to use Spring Boot to develop the application and to see practicals, right? So before we start to write the code or understand any of the demonstrations, first we need to understand why do we even need to use Kafka? What problem it is trying to solve? Because without understanding, Kafka will just become another tool to memorize, which is not helpful, right? Now, whenever we develop the application, we follow different patterns. We have monolithic applications, we have microservice applications, right? Both of them follows its own architecture. And the question here is, how two applications communicate with each other? What are the different options available? Let me just pictorially try to demonstrate this. See, coming to the microservices, you must be knowing the entire code base, the entire application will be built as one code base. All the features of the application will be developed as one application, or you can say one code base. And if you want to make a call between multiple features within one code base, within one application, we have internal classes, we have a method call, or you can say internal API call. And if that entire application want to use third-party API, then we can go with the concept of REST APIs, wherein we can make a REST call and we can share the data or take the data. Now, if you want to make a call to one more application, again, you should know the entire details of the another API or application for which you are making call to. You should know the IP address, or you can say know the host name, the port number, the entire endpoints, all the details. Only then you'll be able to make a call to any other application, right? Now, coming to the microservice application or microservice architecture, what happens here is we will develop the whole application as multiple applications or multiple APIs, multiple services, microservices. For end user, it will be like one whole application, but when it comes to development perspective, so many applications will be developing behind the scene. Each of the application can be called as one microservice, one API, one application, or one service, right? Now, the entire service, the entire API will have its own container that will be deployed in its own server. It will have its own database. You must be knowing here, right? Now, if you want to make example behind the scene, we are following microservice architecture. We have multiple microservices, multiple applications, and if one application want to make a call to one more application through HTTP call or through a REST call, then this application, example, the order service make a call to product service, then the order service must know the port number, the IP address of this product service, the port number, or you can say the host name. Only then it can make a call to one more application, right? So example, if order service doesn't know about the product service, then it cannot make a call. It should know where that application is deployed, because maybe the product service is deployed in its own server, or you can say in its own container. So if you want to make a call, then you should know everything about it, where exactly that application is residing, what is the port number, what is the host name. Only then you'll be able to make a call. And in microservice, when it comes to the Spring Boot, we do also have an option of Fiend client, wherein we have to register everything in the API registries, and then we can make a call with this API name. But however, you should know the entire details, and also it is tightly coupled. Example, if order service is making call to product service, and if product service there is some issue, maybe the application is down or some other issue, then it is not responding you back. And since it is not responding you back, order service also will not be able to proceed further, because both of them are tightly coupled with each other. Two services, two microservices, two applications are tightly bonded with each other. It is making call to one more application, one more API, one more service, and it is not responding back. I'll not be able to proceed further, because most of the REST calls, or you can say usually REST calls, are synchronous. You'll make a call to an API, that API is not responding you back, you'll not be able to proceed. Of course, in Spring Boot, we have something called as a reactive programming. There we have a concept of webflex, through which you can achieve asynchronous communication also. But generally, usually, all the REST calls are synchronous only. you'll make a REST API call. If it is not responding back, you'll not be able to proceed further. Or even to make a call to any of the API, that APIs, that applications details also you should be knowing it. And only then you'll be able to make a call to it, and then whatever response you get, then you can able to proceed further, right? It will become tightly coupled. Whatever API you're making a call, if that API there is a problem, it is not responding you back, your API, your service also will be failed here. And that's where the concept of MOM, message oriented middleware, comes into picture. It is a system where two applications, two APIs, two services can communicate with each other without even knowing about each other. Or you can say, with loose coupling, two applications can communicate with each other. It follows a pattern called as producer consumer, where it will introduce a middleman called as message broker. There are many examples: RabbitMQ, we have Apache Kafka, and here we are going to talk about the Apache Kafka. So what exactly happens in the Kafka? It follows something called as publisher subscriber model. What do I mean by that? See, there will be applications, n number of applications, doesn't matter. The application which is going to generate the data or produce the data for another application can be called as producer application. It could be any application in that matter. So this application is the one which is going to produce the data so that the other applications can use it. Now this application need not to know about any other application. That means whatever data I'm producing, who is consuming, it need not to know, and it is not going to get connected to any other applications or services directly. So its responsibility is to generate the data and publish the data into the message broker, the middleware component. That's where the Kafka comes into picture here. In Kafka, we have one component called as topic. It is a place where messages will be stored. Messages you can consider as the data. It could be any object also, doesn't matter. See, example, we have a Spring Boot application and I want to produce the customer object. So I have to get connected to Kafka server, and then I have to publish that data inside the Kafka server, where I have to publish a place which is called as topic. Kafka topic. So what you should be knowing it, you should not know about any other application who's going to consume your data. You should know about the Kafka server location, and you should know about the Kafka topic name. That's all. And to that Kafka topic, you have to publish the data or publish the message. Now all the one who want to take that message, take the data, they have to get connected to Kafka server, and they have to subscribe the data, or you can say they have to consume the data. That application can be called as the consumer application. There could be one consumer application, there could be many consumer applications, it could be multiple also, it could be 1:many also. It need not to be that only one application at a time can consume the data, nothing as such. There could be multiple applications at a time subscribing the data, or you can say consuming the data. Now these applications need not to know who has produced the data. They just need to know the name of a topic from where they have to subscribe the data. They have to read the data, or you can say they have to consume the data. Now here in this case, there are two applications which can talk to each other, or you can say which can interchange the data without knowing about each other. In REST API calls, if you know the development, so if two applications want to call, then the application, they have to make a call to one more API, right? They should know the IP address, the host name, the port number, the endpoints. Only then they can make a call. It's a direct call. And here, if it is not responding back, then there will be issue in your application. That is not the case here. Two applications don't know about each other. They are loosely coupled. In between, we have message broker. So one application will get connected to Kafka, will publish the message into Kafka topic. Another application will go to the Kafka topic and subscribe the data. Take that data with the help of this middleman message broker called as Kafka here. So two applications are able to communicate with each other with loose coupling. They have to get connected to Kafka server. Within the Kafka topic, message will be available. They have to take. One has to publish, one more has to take. So if this is publishing data, doesn't know when the other application is consuming. Its responsibility will keep on publishing the data or producing the data, depends on what type of application you're building. Other application doesn't know who's the one who has published the data, so it will take it. Kafka has n number of benefits. Number one happens to be real-time streaming. So real-time streaming is whatever the data communication will happen between the producer and consumer is very, very fast with lowest latency. You can watch the cricket match or football games where real what is happening in the stadium. There will be so many applications which will give you or which will live telecast to everything, all the scores you can able to see immediately with lowest latency. Immediately what is happening in the stadium, you can see that because they are able to stream the data in real time, right? So whatever data you're going to publish into Kafka topic, right, that message, that data can be subscribed immediately, so called as real-time data streaming, and with high throughput. That means millions of messages can be published and subscribed within no time. High throughput, it can handle at a time millions of messages. So much data can be published into topic, so much data can be consumed or subscribed from the topic. So in one word, if I have to answer, it is a concept where two applications can communicate with each other without knowing about each other, and that too with high throughput, less latency, real-time data streaming, and also it has fault tolerance. That means if something goes wrong with the Kafka server, it will also maintain the backup and the data will not be lost. It has fault tolerance, high throughput, real-time data streaming. There are many other advantages associated with Apache Kafka, which becomes very important for any developer to know, so that you can develop an application which can also manage data or communicate with each other for the data interchange or message interchange with loose coupling with the concept of message broker in middle. We should understand little bit more before we start to actually develop the application or install or download the Kafka server. So the conclusion so far is we will have producer, the one which sends the data to the Kafka broker, Kafka topic, and we have a Kafka topic, the one which keeps the data and stream it, and we will have a consumer, the one which consumes the data, or you can say reads the data or subscribes the data. Now we need to understand little more on the core topics of or core concepts of Kafka before we start to write the code, right? Now assume that this is one of the Kafka broker, or you can say Kafka server. Okay, this is one of the Kafka broker or Kafka server, whatever you call it. And we can have topics inside the Kafka server, right? Assume that this is topic number 1. Whatever is the name of the topic, you can give it. I will say this is topic number 1 or some other name of your own choice. Now, one Kafka server can have more than one topic. It can have multiple topics, okay? Topic, that means it is a place where messages are stored. Once a publisher application publishes the data, that will come and sit in the Kafka topic, and that is what you have understood, okay? Assume that this Kafka broker has 2 topics. Can it have 2 topics? It can have 3, 4. There is no problem. I'll make it as maybe this is topic number 2. Okay, this is topic 1 and this is topic 2. Now, again, this topic can be further divided into multiple partitions because Kafka handles a large millions of messages, right? It has the high throughput and it has to be very fast, right? It should be processing the data with the lowest latency. Real-time data streaming should happen. High throughput, fault tolerance. How exactly these benefits of Kafka are achieved is what we have to understand here, right? So one Kafka server or Kafka broker can have multiple topics. Multiple in sense it can be 2 or 3. And these can be further divided into multiple partitions. It could be 1, 2, 3, 4. Example, I may write here 3 partitions. It's not like only 3. It can be 4, 5, doesn't matter, right? So now, again, similarly, this topic also may have 2 or 3 partitions or maybe 10 partitions, doesn't matter, right? So it will have multiple partitions. Now, why we have multiple partitions here? See, Kafka handles large volume of data, right? High throughput, and also it has to process or it has to support parallel processing, right? Now, suppose this particular topic has only one partition. Producer application is producing the data, maybe large volume of data, and all the data is coming and sitting inside this partition of topic. Now, the thing is, only one consumer can get connected to this partition at a time. Suppose we have one consumer here, okay? This is the consumer, and this consumer can get connected to this particular partition, okay? Suppose we have one more consumer here. Now, can this consumer also get connected to the same partition? The answer is no, it cannot do that. So parallel processing will not be possible without having multiple partitions here. Fine. So if there are multiple partitions, then we can have multiple consumers consuming from each of this. We may have maybe one more consumer here, okay? And this consumer is taking the data, reading the data from this partition. If a topic is having one partition, the rule is one consumer can get connected to one partition only. Suppose there is a Kafka broker. Inside this, we have one Kafka topic. Inside this, we have only one partition where the data will be stored. Now, as per the rule, only one consumer can get connected to that partition. Then the process will be slow. Then it will not be able to achieve parallel processing, and it will be difficult to manage the large data, and system will become slow. Kafka is specialist in fast processing. Kafka is no specialist in the real-time data streaming, right? How all these things will be achieved? That is what we are trying to understand here. So Kafka topic will have multiple partitions, right? Now all these consumers can consume from these partitions, but one rule you remember, that this particular consumer can get connected to only one partition. And again, consumer is the one which reads the data and process it. And again, we can have the consumer groups also, right? All the activities, maybe these all consumers have to do some activity. We can group them and we can call them as consumer group number 1. Okay, let me just name this as consumer group number 1. And this consumer group has maybe 3 consumers. Okay, let me just add this once again, because we can have multiple consumer groups, and in those groups also we can have multiple consumers, one or more consumers. Okay, I would like to just do it. Okay, fine. Now suppose this particular consumer group has 4 consumers. Okay, 4 consumers we have totally in this particular consumer group, and as per the rule, one consumer can get connected to one partition of this particular topic. Fine. Topic is the place where data will be stored. So we will have one publisher application, will publish the data into the topic. Inside the topic, we can have partitions, right? And now assume that there is an application which is publishing the data to the topic number 2. And this topic has how many partitions? 3 partitions. Now, whatever we have here inside these partitions of this particular topic, this consumer group is going to consume the data. Great. Now, consumer number 1 will consume the data here. Consumer number 2 will consume the data from one more partition. Consumer number 3 is consuming the data from one more particular partition. Now, can we have this particular consumer consume the data from the same partition? The answer is no. This is not allowed. One consumer, if it is already occupying this particular partition, one more consumer cannot go to the same partition. Why is it so? Very simple. See, there is one event here. Publisher application is publishing that order is placed. That order place information is coming to this particular topic. Maybe I'll just quickly name this as P1. Okay, and this is partition number 2, and this is partition number 3. Similar to this is partition number 1 of topic, partition number 2 of topic 2, and partition number 3 of topic number 3. Great. Now see here, we have one application here. Assume that there is a publisher application. We have, this is the application which is going to publish the data. This is publisher application. Okay, it is publishing something in the topic of topic 1 of partition 1. Maybe the order is placed. Great. Now from there, assume if 2 consumer application is consuming the data, this also consume, this also consume, then don't you think that 2 orders will be placed? It will be considered as though 2 orders are placed, because order is placed 1 that has been taken here, but 2 application is consuming that oh, order is placed, order is placed. Somewhat behind the scene, there will be data inconsistency. It will go as 2 orders are placed. To avoid this data inconsistency, there is one rule. What is that rule? This, we have a partitions of this topic. If someone is publishing some message in this partition number 1, one consumer only can get connected and read the data. 2 consumers at a time cannot go to the same partition and collect it. Fine. Now, in one case, it is possible. What is that one case? Suppose, okay, let me just quickly give names to this. This is consumer number 1. Okay. This is consumer number 2. This is consumer number 3. Similarly, we have consumer number 1. We have consumer 2. We have consumer 3. We have consumer application number 4. Okay. C4 is what I have given here. Great. Now, one thing you have to understand is that as per the rule, Kafka broker can have multiple topics, just to conclude, and this topic has multiple partitions. Okay, great, wonderful. Now, from this partition, only one consumer can get connected and read the data. Multiple consumers of this group cannot get connected to same partition and read the data because of data inconsistency. To avoid that, great. But suppose this is a group number 1 and this is consumer group number 2. Now, this partition number 3 of topic 1 is already been consumed by consumer number 1, okay, of consumer group 1. Now, same place, consumer 1 of consumer number 2, or it could be any consumer, guys, number C1, C2, C3, doesn't matter. This is trying to read the data from the same partition. It is allowed. What do you mean by that? Just now I have told one thing. What is that? One partition, if there is a data, 2 consumers cannot get connected. That is true. But 2 consumers of same group cannot get connected. 2 consumers of different group can get connected. So in that case, can we have a also conclusion that one consumer can get connected to 2 topics and 2 different partitions? One consumer can get connected to 2 topics and 2 different partitions. That is allowed. Can one partition be connected by multiple consumers of same group? The answer is no. I hope you are able to get here, right? Suppose we have a consumer group, we have multiple consumer applications, and we have C2, consumer number 2, consuming the data from partition number 1. No problem. We can do that. From same partition, can consumer number 2, consumer number 3 also consume? Answer is no. It will lead to data consistency. It is not allowed. Maybe this all consumers are there to manage the orders, like how many orders are getting placed, they want to manage. Now, order is placed, one customer has placed the order, example, the details have been stored here in the partition number 1. So one consumer is consuming and it will do his task. One more consumer, same partition if it is going, that means 2 of them are reading the same data. Then it can lead to some problems. It can lead to data inconsistency, and it should not be like 2 orders are placed. But in reality, only 1 order is placed. To avoid this only, we have a rule that one partitions, only one consumer can get connected. But if there is a consumer of different group, can it get connected to the same partition? That is allowed. Same group, we can have multiple consumers, but those consumers at a time can get connected to only one partition. I hope this picture you could able to understand here. Fine. So just to conclude the things here, producer is the application which publish the data to Kafka topic. Consumer is the application which subscribes or read the data from Kafka topic. Now, in one Kafka broker, in one Kafka server, we can have multiple Kafka topics, right? And one Kafka topic can have multiple partitions. It will help to scale. It will help to make it flexible. It will help for parallel processing of the data. It will help in managing high throughput data. Millions of messages can be managed if there are multiple partitions here, right? Now, how it will manage at the time of publishing the message to the Kafka topic? Now, it doesn't know publisher that my message which I'm publishing to this particular topic is going to partition 1 or partition 2 or partition 3. It doesn't know that. It will by default follow something called as a round robin technique. Message will go to P1, then P2, then P3, then P4, P6, P7. Unless and until the publisher application explicitly specify with a key that I want to publish in this particular partition of the topic, then you can do it. So at the time of you publishing, alongside the topic name, if you specify partition key also, then you can be rest assured that whatever message you are publishing to the topic, it will go and sit in a particular partition. Suppose if you don't specify the key, if you don't specify the partition, then you are publishing to a topic. Inside this topic, in which partition your message will go and sit, you cannot decide. That is what I am trying to say here. I hope you got this picture here. Publisher will publish the data. Consumer will read the data. Kafka topic will store it, and Kafka topic again can be divided into multiple partitions. Okay. Now, the best part about the Kafka is it can have multiple consumers getting connected to it and subscribing the data. Suppose we have multiple consumer groups doing the activity. In this consumer group, we have 4 or maybe 3 consumers. All of them are getting connected to a topic, and each consumer can get connected to only one partition of a topic. Can it get connected to one more topic, different partition? That is fine. Okay. Now this partition, can we have multiple consumers at a time? All those consumers are from the same group? No. So this particular topic can have a partition, and from this partition, one consumer of one consumer group only can read it. From the same partition, from different consumer group, can a consumer get connected and read the data? Yes, this is allowed. I hope this is clear to you before I talk more on the core concepts of Kafka. Now let's understand little more on the Kafka before we actually start to write the code, right? How Kafka achieve fault tolerance is what we have to understand. Assume this is a Kafka cluster wherein we have multiple Kafka brokers, or you can say multiple Kafka servers. It can be in the same locations or it could be maintained differently, right? So one application will get connected to one particular, Kafka broker. Inside the Kafka broker, of course, we can have one topic, we can have multiple topics. Everyone knows that already. I'll make an assumption that we have one topic here. It could be multiple also, as we have seen here, right? So we have one topic here. I'll say Kafka topic. Okay, it could be multiple topics also. Usually our application gets connected to this topic only to publish the data or to subscribe the data of this particular Kafka broker. Now we can have multiple Kafka brokers also to achieve fault tolerance. If something goes wrong to one broker, right, everything whatever we whatever happens in one particular broker will be replicated into different brokers also. By chance, if something goes wrong in the broker number 0, automatically the boss, the one which maintains the metadata of this entire Kafka cluster, will shift everything to the Kafka broker number 1 because it has everything what it had already in the Kafka broker number 0 to achieve fault tolerance. If something goes wrong into one server, the application should not be affected, right? So we can have multiple Kafka brokers here. It could be maintained in same location or a different geographical location. So we have a Kafka topic here, and you know very well, every Kafka topic again will have multiple partitions here. Okay. Assume that we have partition number 1, partition number 2, and partition number 3. Now again, all of these things, whatever we have here, let me just add this here. Okay, I'll pictorially create these copies of this in almost all of these brokers. Let me just do that. As you can see, I have represented pictorially. Okay, so we have multiple partitions here. Again, in these partitions also there will be something called as leaders and followers. This partition will be leader. Okay, I would just represent leader maybe in the green color, and these two partitions which we have here in the white color will be followers. Okay, these two will be followers which are maintained in different Kafka broker. So whatever happens here in the partition number 1 of Kafka topic of broker number 0 will equally replicated in partition 1 of this Kafka broker number 1 and partition 1 of Kafka broker number 2. So these two partitions which are maintained in Kafka broker number 1 and Kafka broker number 2 are called as followers, and this will be the leader. So all the producer consumer applications will talk to only leader, not the followers here. Example, so we have one partition, right? We have partition here also in the broker number 1, in the broker number 2 also. Actual application will get connected to Kafka broker 0. Inside this we have a topic, inside this we have partition number 1. So you're publishing the data to this partition, you're subscribing the data from this partition. Whatever you're doing with this partition, each and everything will be replicated in its followers. We will have one follower in Kafka broker number 1, we will have one follower in the Kafka broker number 2. Same goes here also. Maybe this time this is the leader, these two will be the followers. Maybe this is the leader, these two will be the followers. Example here, in this case, partition number 2 is a leader. Okay, in this case, partition number 3 maybe will be the leader. So if this is the leader, then these two, partition number 3 of Kafka broker number 1 and partition number 3 of Kafka broker 0, this will be the followers. Okay, I would like to say here, this will be the follower. So now this P3, partition 3 of Kafka broker number 2, it is a leader and these two will be followers. Now application will talk to only leaders, not the followers. They'll maintain everything, whatever is happening here. If something goes wrong to is exactly whatever was happening in Kafka broker number 2 within these partitions, everything is replicated here also in the Kafka broker number 1 within this. So if something goes wrong in this entire server is crash or something happened here, nothing to worry because we have one more broker which is doing exactly same time. Then again the metadata will be maintained by ZooKeeper and it will decide who will be leader, because example here P3 was the leader, okay, and something has gone wrong to this particular Kafka broker. Now we have only two things left out. Now if someone is trying to get connected to this P3, it was a leader because publisher and subscriber application has to get connected to the leader only, but this entire server is gone. Now only two of them are left out. Now anyway, whatever was happening here is maintained in this followers also. P3 follower in the Kafka broker number 1 and this P3 follower of Kafka broker number 0. So everything was replicated here equally. Now something has gone wrong here. Need not to worry. Internally, the ZooKeeper, the one who's maintaining the data, will decide who will be the leader among them, and the process of publishing and subscribing will keep on continuing without any problem. And here is how we achieve something called as fault tolerance. Fine. So what I'm trying to say is we will not have in the production, in the real time, we will not have only one Kafka broker. If it is only one Kafka broker, if something goes wrong, everything is gone, right? We will have multiple Kafka brokers. In every Kafka broker, Kafka server, we will have the Kafka topic where the message has to be delivered or message has to be published or subscribed from. Within the topic, we will have the partitions, okay? This could be the partition. And again, whatever happens here in these partitions, what I'm trying to say is everything will be replicated into another Kafka brokers equally, right? This will be in that again, whenever you are replicating, suppose that this partition has 3 or 4 replicas. Those 4 replicas which we have in broker number 1, broker number 2, broker number 3 will be called as followers, and this will be the leader. So actual application will get connected to this partition number 1, will talk to it only. If something goes wrong here, whatever was happening here, the followers are maintaining everything. So you need not to worry. Again, automatically the one who is maintaining the metadata, right, the boss, ZooKeeper, will decide who is the one will be the leader next, because this leader is gone. This entire broker is only down. So leader is also gone. So among these two, who will be the leader? The Kafka ZooKeeper will decide, and every traffic will be forwarded to this particular partition. And here is how the fault tolerance is achieved in the Kafka ecosystem. Now we have one more term here called as ZooKeeper. ZooKeeper is the one which maintains the metadata of your entire Kafka cluster. How many brokers are there? Which is the leader broker? How many partitions are there? Which are the topics? Which is the leader partition? Which is the follower partition? All these details will be maintained and managed by something called as ZooKeeper. ZooKeeper is a centralized system in the entire Kafka ecosystem, which is kind of manager which manages your entire Kafka cluster. How many servers, how many Kafka brokers we have, how many topics we have, how many partitions we have, who is the leader partition, who are the follower partitions. All these details will be maintained by ZooKeeper. It was the case till Kafka 2.8. From Kafka 2.8, we have something called as Craft, which is like enhanced version of this entire system, wherein without ZooKeeper only you can manage everything. So as discussed, this is what I was trying to say, wherein we used to use ZooKeeper in order to manage your entire Kafka cluster, all the brokers, wherein it used to maintain the metadata, leader election out of all the brokers, who is the leader, for which brokers we have as a replicas, right? The controller node, the one which manages the other brokers, health monitoring. Basically, it is the one which coordinates the entire Kafka and make sure everything works. It used to maintain the metadata, and it is the one which starts the Kafka server and will decide who will be the leader, which are the replicas. By chance, if one of the broker is down, who will be the next leader, the leader election, everything used to be decided by ZooKeeper. Just to conclude, if you had to work with Kafka, ZooKeeper was mandatory. That is not the case from Kafka 2.8. We have a Craft, or in simple terms, we call it as K-Raft mode, wherein internal Kafka has its internal built-in metadata, the one which maintains the entire metadata of your Kafka. It will decide the leader election, wherein whatever we used to do with the help of ZooKeeper, that is not needed from Kafka 2.8 onwards. But for a long period of time, if you had to work with Kafka, ZooKeeper was mandatory, and we used to work with ZooKeeper as well, the one which we uses to manage the entire Kafka cluster, or you can say Kafka ecosystem. Right now, you have an option whether to go with ZooKeeper or you don't want to go with ZooKeeper. That will not have any impact on the applications which we are going to develop here. Okay, the Spring Boot application. At the end of the day, we have to make sure that Kafka server is working and our Spring Boot application can get connected to that Kafka server and perform the operation of publishing the data or subscribing the data from Kafka topic, and for which whether you're using ZooKeeper to start the Kafka server or you're going with the Kraft mode, it's up to you. You have to decide that. We will see what is ahead of us because we are going to see everything practically here, right? So now the conclusion here is you can work with Kafka with ZooKeeper, without ZooKeeper. Both of them are allowed at this particular stage. Earlier, ZooKeeper was compulsory. Okay, that's what I want to say. Now, before we start the hands-on, just to conclude our discussion, the important components which we have discussed: producer, the one which sends the data to Kafka, publishes messages to Kafka. Okay, it can choose the partition inside the Kafka topic where you want to publish inside the which partition with the help of key, or if it doesn't decide which particular partition, with the concept of a round robin technique, automatically your data will be assigned to any of the partition of your topic. Okay, and the producer need not to know which consumer is going to consume the data. Both the parties, producer and consumer, they can be independent of each other. They need not to know about each other. You can publish the data without knowing about the consumer, and consumer can subscribe the data without knowing about the publisher or producer. Kafka topic, again the very important part, the logical category or stream of data. Messages are stored inside the partition which are there inside the Kafka topic. It is a place where messages are stored, where publisher will publish and subscriber will subscribe the data from this particular place. Partition, it is a part or unit of a Kafka topic which provides parallelism. Messages inside our partitions are in proper order, and every message will be given some number. That's where the offset comes into picture. Then we have consumer, the one which reads the messages from Kafka topic. Okay, consumer asks Kafka for data, and every consumer will belong to a particular consumer group. Then we have a consumer group, a group of consumers working together to consume or subscribe the data. Each participant, only one consumer in the group can get connected to. If there is a topic and if there are multiple partitions, and to one of the partition, only one consumer of a same group can get connected. Multiple consumer to same partition, we cannot get connected, and that's what we had tried to understand. It will help you with the scalability, load balancing, and the fault tolerance. Then we have seen the last, the broker referring to the Kafka server that stores the data, the one which handles the producer and the consumer's request. Okay, so one cluster can have multiple brokers that can be managed with the help of Kraft or with the help of ZooKeeper. This is the basic core concept or theory of the entire Kafka ecosystem. If there is any issue, you can rewatch the entire video anytime you want and revise whenever you need before you get into hands-on. Now it's time to get into hands-on with the Kafka and the Spring Boot. Now let's go for the installation, and I would like to follow the approach we have been using the ZooKeeper. I would like to run the Kafka server, right? Now for which you can open any of your favorite browser and search for Apache Kafka. It will redirect to this page wherein we have an option of kafka.apache.organization. Just click on this, and then on your screen you'll have this page, and click on downloads and it will redirect to this page. We do have the latest version. If you want, you can go ahead and install this. See, whenever we have an option between latest version and the stable version, I would like to prefer the stable version. Okay, any of the stable version you want, you can go and install, right? So I would like to just click on this. Okay, maybe let's go with 3.9, and you can just go with TGZ file. Okay, I would like to just click on this, and within no time, based on your speed, this particular software will be downloaded in your machine. Let's wait for the download. As you can see, it has been downloaded. Okay, I would like to just extract here. Right click. We do have an option of extracting, and I would like to just click on extract. So within no time, this will be extracted. Okay, so now I would like to just take this extracted folder, copy from here. If you want, you can keep it here also. There is no problem. But I would like to just copy from here and go to my D drive. And in my D drive, I would like to add this particular folder. You can see here the folder has been added. If you want, you can rename also, no problem. Now, if you just open this folder, and we'll have this option of bin, config, libraries, licenses, okay, all of this. And if you just open the bin, we do have this option. See, it downloads both the distributions, okay, the Linux distribution as well as the Windows distribution. And if you are on the Linux machine, then you have to write .sh files. You have to run the sh files to start the ZooKeeper or to start the Kafka server. Now, since we are on the Windows, I would like to just go here on the Windows. We do have an option here, okay. See here, Kafka topic. If you want to run the Kafka, or if you want to create a Kafka topic, this is a command you have to run. We have Kafka server.start. We have Kafka server.stop to stop the server. If you want to start the ZooKeeper, also will have an option here itself. You can see ZooKeeper server start, ZooKeeper server stop. Okay, these are the commands which you have to execute, but it needs some property file. Those properties files are available within this configuration. Okay, you can keep it here only, and from there you can execute, but again you may have to write complex commands. So what you can do is, see here we have care apt also if you want to go with, but I would like to go with the ZooKeeper itself. Now you can see we do have an option of server, and we also have an option of ZooKeeper, which is property source file. You can see here property source file. These files has to be executed. Okay, now I would like to just do one thing. This and the ZooKeeper I would like to copy from here. Okay, just I'm copying here to make sure that the way to start the server becomes easier. If you want, you can keep it here without copying, without adding this into a different folder. You can start ZooKeeper, you can start the Kafka server, and you can make things works. But again, the commands which you have to run will be little complex and not so friendly. So what I'm going to do is server and ZooKeeper, I'm just copying from here and get back to my bin. Within the Windows, I would like to paste it. Okay, now if this is the case, it will be easier for us to start this. Now if you want, you can open this and check here. I'll say ZooKeeper, right click. I'll open this in the notepad. Let me just click on this. As you can see, I have opened this, and you can see here we have a client port 2181 that shows that ZooKeeper runs on this port number or listens to this particular port number. Similar to that, we do have one more which we may have to execute, which is the server.properties. I would like to open this. I'll say here the maybe edit in the notepad, and you can see we do have this. You can see the broker ID number 0. By default, the first Apache Kafka server which you're running, that will be considered as the broker 0. Apache Kafka broker 1, broker 2. Okay, that's how the things works here. And you can see here it is listening to the port number 9092. On the same system, if you want to run one more brokers, then of course two applications cannot run on the same system on the same port number, right? That's not possible. So we may have to open this file, and we may have to edit this just in case if you want to have multiple brokers. If you want to go with the replication factors, if you want to have multiple replicas of your Apache broker, then you may have to open this file. You may have to change the file name, and the port number also has to be changed. Of course, it is commented right now. You can just uncomment and you can change this. Okay, and you can see here the broker ID by default is 0 here, and that's the default first Apache Kafka broker. If you have multiple, that will be 1, 2, 3, 4. You may have to change, but right now it is 1. There is no problem here, and I would like to keep it as it is. Now, if you want to run this, then you have to open within this Windows only. Kafka bin is there, right? Windows, we may have to run this command Kafka server.start, ZooKeeper server.start.bat. All of them are batch files, and we have server .properties files and ZooKeeper .properties files. We have kept it here itself. And one more thing is, you can observe here in the server .properties, the ID is 0. That's the default one. And apart from this, one more thing you can see, the number of partitions is 1. That's the default number of partitions. If you want, you can create multiple. At the time of you creating a topic in the Kafka broker, in the Kafka server, then you can specify how many number of partitions you want. It's up to you. The moment you start the Kafka server, the default number of partitions will be always 1. That's what I'm trying to say. If you want, you can change this also. So there is no problem there also, right? Now let me just get back here. and I would like to start this. Whenever you want to start this, then you can open in your Windows start the command prompt. Always open the command prompt as run as administrator. You have to open this and it will ask you the permission, give it as yes, and you can open this command prompt. I have opened. The moment you have searched cmd run as administrator is what you have to open this. Okay, now what I'm going to do is, it is in the D drive. All right, so I would like to just say here, get into the D drive, and again inside the D drive, get into this Kafka folder. Of course, not alongside this. Okay, that's the name of the folder which I may have to give. All right, so this is the name of the folder I want to get into, and inside this I'll say here, get into the bin, and inside this get into something called as Windows. From here is where we have to start this. How do we start? You can see here we do have this folder, right? We may have to start this ZooKeeper first, and then we may have to start the Kafka server. To start the ZooKeeper, we have this command here for the Windows machine, which is ZooKeeper -server -start. You can see here down. So this is what we may have to start. Alongside this, we have to specify the ZooKeeper properties file. Okay, same thing I would like to just specify here also. I will say here ZooKeeper -server -start .bat. Okay, and the name of the property file is ZooKeeper .properties. Let me just specify here, and I just have to run this. The moment I run this, you can see ZooKeeper will be started. I would like to allow this. Similar to this, I have to start the Kafka. Again, you may have to open this command prompt in the run as administrator mode only. Okay, you have to give the permission, and again I would like to just get into this. I'll say here get into the D drive, and then I have to just specify maybe get into this particular folder, which is Kafka. This is the name of that particular drive. I would like to just remove this. Okay, and I would like to just hit this cd bin, and I want to get into this Windows. All right, now to start this, you can see here we have to run this command Kafka, right? If you want to start, they have Kafka -server -start .bat for Windows .sh for the Linux and other distributions. Okay, so let me just do that here. I will say here Kafka -server start .bat, and what is the name of the server .properties file? This name is what you have to specify, which we have copied, server .properties file. Okay, so I would like to just get into this, and I will say here server .properties file, server.properties file, and I would like to hit this. Okay, so we got one error here. Vimic is not recognized as an internal or external command, operable program, or batch file. We may have to first resolve this issue, and this problem can be resolved by getting into this folder, or you can say file. So we have an option here, Kafka server start. Okay, a bat file. I would like to just say here edit in the notepad, and I would like to just edit this. What you have to do here is you just have to either remove this particular line. If not, you can just replace this everything. Okay, just remove this whatever lines we have here. Okay, I would like to just remove this, or you can just say comment it. Okay, this is more than sufficient. Just keep only this much. Okay, so I would like to save this. After saving this, again I would like to try to run the same thing. Okay, I will say here Kafka server start .bat, and I have to specify server .properties. Okay, let me just specify, and you can see Kafka server is also starting, and that problem is also resolved. Okay, can we have multiple brokers? The answer is yes, you can have multiple brokers also, for which what to do is I would like to just get back here. If you want, you can have the broker in a different location, but I want to have the local machine only. We have the server.properties, right? I would like to take this one more time. I will add in the same. Okay, and I'll just rename this as, I'll say here, okay, rename this to server2. Okay, the same server.properties file, I'll rename it to server2, and here I'll say right click, and we have an option of edit in notepad, and we have to change this. See, broker ID will become 1, because that is already we have one broker running, which is with the broker ID 0, and this port number I will change it to 9093, because the default port number for Kafka which is already running is 9092. Okay, I will just uncomment. Of course, this is commented. I would like to uncomment. So this is one more change you have to do. And apart from this, the logs file also would be generated. That name also you may have to change. Okay, so I'll just give it as maybe logs2. Okay, that's what I would like to do here. After doing these changes, I will just get back to my machine. Okay. Again, I would like to run this particular file. Okay. So what I'm going to do here is, so again, I'll open my command prompt in the run as administrator mode. It will ask me the permission and I may have to open this. Okay. So once you open this, again, I'll just get back to the D drive. And in the D drive, I'll just specify the name of my folder. As you can see, I have specified this. Okay. And again, I will just get into seam, which is bin, and get into, maybe I'll say here Windows. And I would like to just specify, okay, of course, I have to get into Windows and we are here. And we have to do the same thing here. I would like to just specify Kafka, I'll say server hyphen start dot bat, and this time it is server 2 dot properties. Okay. Now we will have two Kafka brokers running. See, it is also running fine without a problem. We have two Kafka servers running here. Fine. I hope you could able to understand what is the one changes we have done it. If you wanted to have more Kafka broker. So now ZooKeeper we have started, and also we have started the Kafka server. We have started in fact two Kafka servers. We have not created any topics and we have not specified how many partitions we need. That we may have to see here. Okay. Now let's create the Kafka topic again, right? So we have an option here, Kafka. We have started the Kafka server by running this command Kafka server dot start dot bat and ZooKeeper server hyphen start dot bat. And similarly, we do have one more here called as Kafka topic. Same thing we may have to use if you want to create a Kafka topic. You can see here Kafka topics we have. Again, I may have to open the command prompt again in the administrative mode. I hope everyone in the class knows how to open a command prompt. Okay. And I would like to just navigate into my Kafka server. Let me just do that here. I have navigate into the exact path from where we may have to run these commands. Okay. So I would like to just run one command here, which you can see on your screen. I will just add this Kafka topics dot bat create hyphen topic. Telusko is the name of the topic which I have given here. If I have to zoom a bit, then you can see localhost. That's where we have a broker 0 running in. And I have told I need 4 partitions, and replication factor I have told 2 here because we have 2 Kafka brokers running. By chance, if you have single Kafka broker running and if you say replication factor 2, then it will throw an error. Right now, since we have 2 Kafka brokers running, and when I have told replication factor 2, it has not created any problem. And you can see here, created Kafka topic by the name Telusko, right? Now, in place of this, if you would have given 3 or 4, then you would have got error because we don't have 3 or 4 Kafka brokers. We have only 2 Kafka brokers. Only if you have started 2 Kafka brokers, you can give the replication factor 2. If not, you can just go till the partitions. You can have any number of partitions in one topic and you can create multiple topics, and inside this, you can create multiple partitions also. Fine. Now we can also check here how many partitions and replicas created, for which we may have to just run this command. I would like to just specify the command. You can see here Kafka topic dot bat describe topic Telusko, and in this particular port number, whatever broker is running, how many replicas we have to specify. There are totally 2 replication factors, and the partition count is 4. If you want, you can list out the topics which has been created so far, for which you just have to run this command Kafka topic hyphen list bootstrap server localhost. In this particular host, whatever server we have started, the main server, the leader. So this is that Kafka topic Telusko which got created. Okay. So now what we have done is we understood the core of Kafka, why we have to use all the important core concept. Then we have started ZooKeeper, we have started Kafka server. In fact, we have started 2 Kafka brokers, and then we have created the topic, and in that topic we have also created the partition. Now it's time to start the journey with Spring Boot application. Now let's develop the Spring Boot application, a publisher application which can publish the data into the Kafka, and a subscriber application which can subscribe the data, or you can say the consumer application. Okay, producer and consumer, that's what we may have to develop here. For which I have opened the Spring Initializer. You can develop this using the IDE of your own choice, Spring Tool Suite, Eclipse IDE, or maybe the IntelliJ IDEA. That should not be the matter of concern. The code going to remain same irrespective of the IDE you're going to use. Okay, so I have opened the start.spring.io, and I would like to develop a Maven Java project, and I would like to go with a stable version, and the packaging, let it be com.telusko, and the artifact I would like to give it as maybe publisher, or you can say here producer application. Okay, I'll say here producer. Okay, that's the name I have given here, and let the package name be com.telusko.kafka. That will be a relevant name. Okay. So producer application jar dot properties are YAML. It's up to you. I'd like to go with the dot properties itself. If you want, you can go with the YAML also. So that shouldn't be a major matter of concern. Okay. So dot properties 7, or let's go with the YAML itself. It will be easier. Okay. And now the dependencies. I want to develop the APIs for this web, and I want the auto reload, dev tools, and for Kafka, since I'm going to just publish the data and subscribe, so this is more than sufficient. Stream is not required. If you want, you can add this also if you're doing something advanced, but I would like to keep it this. Okay. And then other dependencies depends on the need of the application. Whatever you want, you can add. The prerequisite, as I said, the one who is watching this might know the Spring Boot. That is what I have kept in my mind. The required dependency have been added. If you want, you can add a data JPA, MySQL database, or Lombok, or whatever as and when needed, or what type of application you're building based on that. But just to get connected to Kafka server and publish your message, this is more than sufficient. I would like to generate this, and the ID which I'm going to use here is Eclipse. Okay, I have opened the Eclipse ID. Now that will be available on the downloads, and I will add that project into Kafka demo, and I'll just import that project. Let me just do that. As you can see, I have added the project and also I have extracted. Okay, now I would like to open my IDE and the file. I would like to just import the existing Maven project which we have developed. I would like to browse this and get this application into my IDE. You can see here, we have this application, producer application. This is the path. When you open the pom.xml, so we have this required dependencies which is needed. Now I would like to just get into this com.telusko.kafka. We have main application, and let's build or develop one package here, or create one package here, dot model. What type of data you want to publish, or what type of data you would like to work for this application. Okay, so now let me just refresh, and I would like to create maybe whatever you want. You can create customer, student, employee. I would like to go with maybe course. That's the data I would like to work with. Okay, now I have created this, and here I will add few fields, setters, getters, constructors. I'll just create one, a basic Pojo here, a model class on which I would like to work with. I hope those who are watching, they know Java, they know Spring Boot. So this small thing should not be a matter of concern. So let me just quickly add that here. As you can see on your screen, I have added few fields: course ID, title, trainer, and the price. And we have setters, getters, toString methods. Okay, basic Pojos. This is ready. On this model, I would like to develop this application. This is the one which I want to publish. This course object as a message I want to publish into Kafka topic. Now I would like to just go here and develop maybe two more packages. One to have our service. So I'll say here dot service, where we'll write the business logic, the main application which is to publish the data into the Kafka server. And I would like to have one more package where we'll develop our controllers. Okay, I'll say dot controller, where we will develop our API, REST API. Let me just quickly refresh this. And here I would like to just go and develop one particular, I would like to say here one class here. Name of the class could be anything. I'll just go with maybe Kafka controller. All right. And here we will have one more. Maybe I would just first define. You can define in the interface and then you can write, or you can just go with the code directly. I would like to just specify here maybe Kafka service. Okay. Kafka producer service or just Kafka service. Anything is fine. I would like to specify. Great. Now what is required? In order to publish the data, in order to send the data from Spring Boot application to the Kafka broker, to the Kafka service, or to the Kafka server inside that Kafka topic, we use something called as Kafka template. Like the way we have a JDBC template, a REST template, we do also have a Kafka template, which can be used in order to send the data from this publisher application into the Kafka topic, or you can say Kafka broker. Okay. So this is a service method where we are going to write the actual logic of this application. All right. And in order to work with Kafka template, I would like to ask the Spring IOC to perform the dependency injection. I'll say here private and Kafka template. The key I would like to work with is a string, and the type of the data I would like to work with is the course. Okay. And I will just say here Kafka template because it is a generic, and I would like to ask my Spring to perform dependency injection. But how Spring will know how it will configure the Kafka template, because the location of the Kafka server will be different, right? In your case, it could be different. In my case, it will be different. I have to configure those things in the application.yaml or application.properties. Okay. Here is where we have to write where is our location of the server, what is the name of the topic. If you want, you can specify that, or if you want, you can hard code in the Java code itself. However, in the application.yaml file, I'll specify the location. Okay. How it has to send the data, it has to serialize the key, it has to serialize the object, the actual message, and then I want to send that data to the Kafka server. Okay. Now the next is I would like to say here public, and maybe the response could be string type of response. I'll say here send the message. That's a name I would like to give. And what is the type of the data we are sending here? I would like to accept here. Okay. I'll say here course type of course. Okay. And then I may have to specify what we will specify. We will just see here. I'll just say here maybe the course message sent to Kafka server. That's what I would like to say. Okay. But before that, I would like to take this Kafka template here, and I will say here Kafka template dot send. We have multiple options. You can see here send. What is that you are sending? See here, we can say only topic, key, and the data. Only topic and data also you can send, and topic, key, and data you can send. Key, if you specify, it will go and sit in a specific partition only, because you're specifying the key here. If you don't specify key, it's like topic. Inside the topic, we had created 4 partitions, and it can go and sit in any partition out of 4 which you have created while creating the Kafka topic, right? So I want to go with this, and the Kafka topic, if you want, you can specify. If not, you can include that in application.yaml or properties file. From there, you can use value annotation and read that directly. Only I'll specify here this is the name of my topic, and the key, what is the key you want to give? So maybe the key I would like to give it as a course, and the object also I would like to give it as course. Okay, that's the object we are working on. We are sending this, and the return type of this, if you want, you can see this also. Okay, I will say dot, I'll say send here. The return type of this is complete. You can see here we have here completable future. It is asynchronous. That means after sending, even if there is no response that whether they have consumed or not, it can do further whatever activity you want to do. It will not wait for the response. It is asynchronous call. Okay, if you want to do something after the response, then you can configure this interface, but I would like to keep it simple. Okay, so let me just specify what I had told. Great, done. So this is the Kafka topic. This is the key. That means I'm specifying which key or which partition I want to add this specific partition. Okay. If you want to send a new data into different partition, you can give a different key. With the same key, if you keep on adding the data, this will go and sit in a specific partition of a topic. Only one partition. Even if you have 4 partition, it will go and sit in a same partition only. Okay, I have specified this. Wonderful. Now I would like to just go back to my controller. I'll develop one API here. I have one REST controller. Let me just specify here one annotation. You know these annotations very well if you are into Spring Boot. Okay, so I would like to specify this is a REST API class, and let's go with the class level mapping also. I'll say here request mapping, and I would like to give it as maybe Kafka as the endpoint. Okay, great. And now I would like to develop one method here. I'll say here public response entity. Okay, and the response string type of response I want to give to the client. I'll say here maybe add course. All right, and you know very well, if you want to read the data, I would like to specify this is the data I want to accept from my REST client, and you have to specify one annotation here called as request body. Okay, this is about the Spring Boot, guys. If you want to not take any data in the post request from any of the REST client, you have to specify this. Okay, so then we have to specify what type of request it is. It is the post mapping. Let me just write down, and the endpoint I would like to decide here is maybe I will say here add course. Okay, that's the endpoint I would like to give it. Right now I will just auto wire this service. Okay, Kafka service I would like to auto wire. Let me just get into this, and of course I'll say here private Kafka service, private Kafka service type service is the name of a variable, and I would like to auto wire. Okay, this is purely dependency injection and inversion of control, guys. I hope you are aware of how we develop the REST API applications or Spring Boot applications. Okay, for the demonstration. Now I would like to say here service dot, and I have to just invoke this message, send the message, and I would like to send this. Great. It will give you some response which I would like to store it in, maybe as a response, and then I may just have to generate here. I'll say a return response, and let me just write down here. As you can see, I have added the response also. Okay, this is the response which I would like to give to my client once I'm able to send the data. So controller part is okay, nothing much is needed. And in the Kafka service, we have to use Kafka template to send the data. And to read the data, to subscribe the data, we have to go with Kafka listener. Okay, we will see that in the subscriber application, but to publish, this is sufficient. Now we may have to configure the application.yaml. Okay, so let me open this, and you can see it is not opening here. Maybe in the Eclipse IDE, I have not added this YAML, but no problem. It will open in a different ID. That shouldn't be a major concern. Okay. So I would like to just, whichever ID this file is opening, is not a problem. Okay. So I would like to add the remaining properties here. We may have to first add here the location of our Kafka, which port number it is listening to, where it is available. And then whatever we are sending the data, the Kafka cannot store this data as it is. Okay. So we are sending this key and value, right? Key is of string type and the value a course object. So Kafka cannot store the Java object as it is, a string as it is. Okay. It will store the data in binary. So we have to serialize the key. We have to serialize this object, and then we may have to send. Okay. So in the application.yaml file, I have to specify the JSON serializer to serialize this Java object, and the string serializer to serialize this key, and the topic anyway I have specified here where I have to store the data. Okay, so let me open this YAML file, and I have to add this here. As you can see, I have added here. I want to deploy my Spring Boot application in 8081 port number, and this is the name of the application. By default, it will be available, and you can see here my Kafka broker is listening to this particular port number. Okay, and this is the key serializer, this is the value serializer. Key serializer is a string serializer, and the value is the JSON serializer. That means I'm asking whatever key value I'm sending to the Kafka topic, it has to serialize and then send. Like the way in Java we have a concept of serialization and deserialization, wherein you're sending the data by serializing, by converting into the bytes of streams. I want to convert that. I want to serialize this key and value, and then I want that to be stored in the Kafka server, because Kafka server will not store the data as it is, the Java object or maybe the string object. You have to serialize. Okay, at the time of subscribing the data from a Spring Boot application, okay, maybe if a Spring Boot application is trying to subscribe the data from the Kafka server, then you have to deserialize. Right now, these things I have specified, and whatever is there in the application.yaml or application.properties file, all these things Spring IOC container will take into consideration, and the Kafka template will be created based on the information we have specified here. Okay, now the Kafka template will have all those information. If you want, you can hard code in the Java code also. All these things which we are specifying the YAML or dot properties file, this can be hard coded in Java code also, but it is not recommended, because if there is any change, every time we may have to recompile the entire project. So all the configuration details must be added in the application.yaml or application.properties file, and hence we have added. Okay, so this is the application, and if you run this application, the data will be published. Now I have to go and develop this subscriber application, the application which is needed to subscribe the data. Let's see how we may have to do that. Now it's time to develop the consumer application, the one who's going to subscribe the data from the Kafka topic. Now to develop the Spring Boot consumer application, you need the same dependencies which we have used there, right? The Kafka dependency, if you open this pom.xml, so this Kafka dependency is needed in order to develop an application which can consume the data, or you can say which can subscribe the data. Rest all the dependency depends on the type of the application you're building. What you have in your consumer application, you may have to add it. So what I'm going to do is, instead of developing a new application, same application I would like to reuse, because the model class is going to remain same. After subscribing, we have to bind that data into our model class, right? It's going to remain same. So I would like to just add and give the name of this class as baby, or project as a consumer application. Okay, so it will take some time, and you can see same dependencies have been added. Okay, so this is, I would like to close it. Whatever application I'm opening right now, it is a consumer application. Okay, so now let me just go with the model. This is the model we have, same model at the consumer end also, so I need not to write or create one more time. And coming to the controller, of course we need not to ask user to, do the post mapping end user, I'll just create one method which is get, and I'll say here get course method also. I'll give it as get course. The one who is invoking this, they need not to pass anything. And of course, we may have to write a few things here. So I'll just go to my service layer. Now, at the time of we publishing the data, we have used Kafka template to publish the data, right? Now we have to use Kafka listener in order to subscribe the data. So what I'm going to do here is, at the top of this, we are going to use one annotation called as maybe Kafka listener. That's the annotation we have to use here, Kafka listener. I have imported, and we may have to pass few or attributes here. So what is it attributes? Number one is topics. From which topic you may have to take that, you may have to subscribe. I may have to specify the name of the topic where the data has been published is Telusko. Alongside that, every consumer will have a group, right? Consumer group. We have seen in the theoretical discussion of the Kafka that when the consumer can get connected to the partitions and consume the data, so we can have multiple consumer in one group. That's what I'm trying to say. So this consumer belongs to one group. So let me just specify the group ID here. And the group ID, I would like to give it as whatever name you want, you can give. I would like to go with Telusko group. Okay, or maybe consumer group, whatever you want, you can give. So that shouldn't be a major matter of concern, right? So now I would like to say here, get the message, and it will just able to capture it. Okay, from this topic, it will take that message and it will come and bind this to the whatever JSON data we are getting, and that will come and sit here. If you want, you can return that. So what I'm going to do here is, so I will create one maybe string type of, let me just give it as void method. I don't want anyone to call and get this. So I'm going to create, this is not required right now. I'm going to create one variable here, maybe string type of message. String type of message is what I would like to create. And now I will say here message variable message, and I will say here equals to, and I'll say here course plus, I will just add some English message. Okay, so got the data from Kafka. Okay, so just to have a differentiating factor in the message, I would like to specify this. Got the data from Kafka topic. That's what I have defined here, and nothing more than this. It's more than sufficient. Now I will write one more getter. So let me just generate one getter for this message. I will say source generate the getters. For this, I want only a getter. So whoever want, they can invoke this getter and get the data which is coming from the Kafka. Okay. If you want, you can just print also on your screen, just in case if you want to see the real time, how fast is able to consume the data. So I would like to print this on my screen also. And this printing is happening on the consumer side. The moment you publish the data, you'll be able to see something on the console of consumer application. And what I'm going to do is, if I invoke from this consumer application, if someone reach out to this particular endpoint, they should be getting the same message. So now I will say here service dot name of this message get message. Okay, and what is that they have to get? I'll not invoke this, so rather I will just get back here. So we do have this get message, right? I would like to invoke this, and this I've given the method name as consume, and now it has to invoke the same getter service dot get message. It will give you this message coming from the Kafka, and same thing I'm going to return to the caller. Now to publish the message, we need a Kafka template. To subscribe, we need Kafka listener, which we have specified here. So this is the consumer application, and we have one more, which is a publisher application, or you can say the producer application. Fine. And it will serialize at the time of publishing the application. At the time of you taking the data, right, you may have to deserialize, for which in our consumer application also application.properties we may have to specify. So let me just open this. In the Eclipse ID, I have not added that YAML file configuration. It is opening the different ID, so that should not be a problem here. So we had used earlier, it is a consumer application. Now I'll say consumer application, and let it be deployed in 8082, and this is the place of my Kafka server. Let it be as it is, no problem. But wherever we have used serializer, we have to specify deserializer. So let me just specify here. As you can see, I have specified. Alongside that, I have told here consumer, okay, group ID. So I think we have given a different group ID. I have to specify the same, which is the Telusko group. So this consumer belongs to this Telusko group. So I may have to specify the same here. So that's the name of my group. Okay. Now the key is deserializer and the string deserializer. and the actual value is JSON deserializer. Okay. Now, alongside this, one more thing you have to specify here. Okay. At this level, which is a child of consumer, bootstrap server, and the child of the Kafka and consumer. What is that? If you ask me, it is the properties. Okay. Spring.kafka.properties, Spring JSON trusted. So what I'm trying to specify here is whatever data we are receiving, JSON data from the, Kafka topic. I know one blindly converting the JSON data into the, Java objects which we have. I only want it to deserialize the JSON data for the classes which are coming under this particular package. Only this is what I want it to deserialize, not everything. So in my application, in the package here, we have one model class, right, course, which is in the package com.telusko.kafka.model. Okay. And I want it to deserialize for the classes which comes under this package. During the serialization also, same package have been used at the time of you publishing. During the deserialization also, I have specified the same thing. Blindly, I don't want it to convert the JSON data into Java objects as it is. So I have specified here, I only want it to deserialize for the classes which comes under this particular package, not everything. That is what I have specified this here. Okay. So now I have told here deserializers for my value, deserializer for my key, and where is my Kafka broker located, that details also have specified. Okay. And the Kafka topic name also, I think we have specified here, from where it has to subscribe the data. Group ID have specified. Now it's time to run this. Kafka server we had started before we developed the application. Now it's time to first run this publisher application, and then we may have to run the consumer application. Now let's run the producer and the consumer application. Before that, I would like to also highlight that small changes I have made here. This was not aligned properly in the consumer, the properties which we have added, right? See, in the YAML, ident spacing is the most important one. Okay. Even if you want, you can just say, I have made the changes. You can see here. So I'll just open this, right click, maybe open with text editor. You can see here, I have made the same changes here also. Okay. In the actual file, because this ident spacing, there was a problem. I have resolved this before running. I would like to just highlight this. Okay. So now first I would like to execute the producer application. So let me just run this producer application. I am just running this, no problem. And now I would like to also get into the Postman tool. It is a tool to test our API responses. If you want to just make a call to any of the REST API, we can go with the tools. In this, I'm using one of the popular tool, which is the Postman. Okay. It's a post request localhost. I'll say colon. The publisher application is in 8081, the producer application. And I think we are having it as Kafka. Let me just open this. And we had only given in my controller, if I have to open, you can see here Kafka, and it is add course. We may have to add the course. Okay. So let me just get into the Postman tool here. Okay. And Kafka, and then I have to specify the entire endpoint. And in the body, I have to add some sample JSON data. Okay. So let me add the sample JSON data here, JSON, and I would like to add the sample JSON data. So course ID Java, maybe title Java Spring Boot, and I'll see here course ID as Telusko 1. Okay, that's the course ID, Telusko 01, Java Spring Boot, Navin Reddy, pricing. Okay, so if I just hit this, I think I'm getting the response. You can see here course message sent to Kafka server. Now let me just go back to my consumer application. This is my consumer project, right? I'll say right click, run as a Spring Boot application. Okay, and I would like to just run this as a Spring Boot application. And you can see here, we are getting this data. Okay, you can see the console, we are getting this data immediately. Got the data from the Kafka when I executed this. If you want, you can reach out to this endpoint also, a get request. So what is the endpoint we have here in the consumer? Get course. It's a get request, get course. Okay, so if I have to make a call, okay, let me just open this. I would like to just make this as a get call. So all this is not required, body and all, if you're making a call. So in place of this, it is get course. Okay, get request and 8082. Okay, if I just make a call to this, you can see here we are getting the data, and this data you're getting from the Kafka server. So one application, a Spring Boot application, is able to publish the data into Kafka server, and one application is able to consume the data or subscribe the data from the Kafka server. two application could able to communicate independently in sense they know that at the time of deserialization I should be writing the same class as it has been used at the time of serializing in the publisher application, but we need not to add the port number, where is the application server details. We need not to make a call like the way we do HTTP calls or REST API calls, right? So one application independent of the consumer, it is publishing the data into the Kafka server. One more application is able to subscribe the data or consume the data from the Kafka server. So this is the demonstration of a Spring Boot application which is using Kafka server in order to produce the data and in order to consume the data. So first we have understood theoretically, and then same thing we have demonstrated practically, and this is what the demo of Spring Boot with Apache Kafka. Okay. So thank you so much for joining me in this entire video. See you in the next video.